Okay, this is from chapter 23, problem 3, which says rearrange the equation current equals voltage over resistance to express resistance in terms of current and voltage. Then solve the following. A certain device in a 120 volt circuit has a current rating of 20 amps. What is the resistance of the device? How many ohms? So the original equation is current I equals voltage V divided by resistance R. So to solve for resistance R means that I get the R to the other side, so I multiply with it, and at the same time I divide by I, which means I have voltage divided by current. There's a third equation that they don't ask for, but I do it anyway, which is that to solve for the voltage V, which means that I multiply with I, so it's R times I. Notice the other equation, of course, gives the same thing. Voltage equals I times R as I get it to the other side. So V equals R times I. And for these here, there are certain representations. One of them is circular and another one is triangular. I'm just going to do the circle here. There we go. And let's see if I see a line that I can use here. Maybe this one. And there we go. And make it black, I guess. There. Alright, there's one. And there's one. And put V on the top. And R and I at the bottom. It doesn't matter if it says R and I or if it says I and R, as long as the V is on top. And what this means here is that V equals R times I. V equals R times I. Or R equals V over I. R equals V over I. Or I equals V over R. I equals V over R. Okay, so that way it can be memorized as well if you memorize this circle or triangular representation. As I said, you can look up triangle, looks exactly the same, except it's a triangle. Anyway, it says that a certain device in a 120 volt circuit has a current rating of 20 amps, so I have V equals 120 volts and I equals 20 amps. What is the resistance? So for that one, since I'm supposed to figure out the resistance, I should use this particular equation. So R equals V over I, which is 120 volts divided by 20 amps, which is 6, of course, and volts divided by amps, that's what the unit would be, but that would be expressed for the standard units for resistance, which is ohms. And of course this is handwriting. Actually, that's kind of pretty handwriting. In the book you may see something like that, but you know, if I don't get that quite right, sometimes I'm a little sloppy. I do this here. Either one of them is supposed to mean ohms, just like this one here is supposed to be an R and this one here is supposed to be an I, and as long as it's legible, nobody is going to complain about it. So as long as we can read my handwritten ohm as an actual ohm, then nobody should complain about it. This problem is from chapter 23, number 4. It says, using the formula power equals currents times voltage, find the current drawn by a 1200 watt toaster connected to 120 volts. Then using the method from the previous problem, show that the resistance of the toaster is 12 ohms. So it says power equals current times voltage. There we go. All capital letters. Find the current drawn by 1200 watt toaster. So the toaster produces a power of 1200 watts, and it's hooked up to an outlet with a voltage of 120 volts. And with that, we're supposed to figure out what the electrical current is. And of course, this one here, as far as the algebra goes, would be that electrical current equals power on the other side divided by the voltage. So divide by voltage. So 1200 watts divided by 120 volts, which of course is 10, and then the unit is watts divided by volts, because we're supposed to come up with electric current in standard units. These are standard units, so we're going to come up with standard units as well, which is amps. So the answer is 10 amps. Then, using the method from the previous problem, show that the resistance of the toaster is 12 ohms. So with that, we're supposed to figure out what the resistance is, and resistance is voltage divided by electric current. So that's 120 volts divided by 10 amps. That of course is 12, and volts over amps would be the units. Again, this is standard units, so for resistance the standard units has to come up, and that is 12 ohms. And as I mentioned before, this is my way of writing it in handwriting, and as long as it's legible and comparable to the way it's printed, then that should be okay.